Hello and welcome to the video of master distributed tracing in Azure Application Insights and OpenTelemetry. Now let's go through some important topics in distributed tracing. Trace and span. A trace is the complete journey. Spans are the timed steps that makes it up. Trace is one end-to-end operation across services and dependencies. Shared trace ID. Every span has its own span ID and usually one parent span ID. The post request here in the drawing creates a trace that consists of 4 spans, validate the order, inventory, HTTP call, and SQL call, and these all spans create a complete trace. Azure stores the same coloration model with different field and table names. For example, in the OpenTelemetry, trace ID is operation ID, operation underscore ID in Application Insights, and in Log Analytics workspace is operation ID. A span ID is ID and ID also in the Log Analytics and so on. So they have their own different name in Azure, but equivalent to OpenTelemetry standards. And one important field name, for example, the attributes for the stamps are stored as custom dimensions in Application Insights because you can search on them, and also properties in Log Analytics workspace. Context propagation. W3C headers carry the active trace identity across processes and network boundaries. And if you make any API calls, this trace information will go to the next step or to the underlying services. The downstream span keeps the same trace and uses the received span as its parents. If on the way a proxy or client drops the headers, then you will lose the track of the traces. Attributes or tags are searchable metadata to a span. They do not automatically propagate. So this means that they will not go from one span to the different span, to the next span. And we can basically add the custom tags to the span, and also we can search on them. Prefer standard semantic conventions. Keep business keys consistent and bounded. Never add secrets token or uncontrolled PII. Span events. An event is a time-stamped annotation inside a span, not a separate business event. For example, in the reserve inventory, we have a start and complete beginning and end of the span. And in this span, we can have or create 2 or many events as we want, like retry event or cache miss event. A span event appears with correlated diagnostic telemetry, commonly in app traces. Custom events and a standalone usage for business signal stored in app events. Baggage is context that travels downstream. Copy selected values to attributes when you need to search on them. For example, in the scenario down below, we have a tenant tier baggage that, as you can see, is able to traverse through different spans. The difference is that baggage available to downstream services. Attributes stay on the span where they set. Baggage can leave the service in HTTP or message headers. Never put credentials or sensitive personal data in it. Statuses and exceptions. Recording an exception and marking the span as failed are separate complementary actions. In the cache block, we have our span, which is called activity here, and we record the exception, and we can set the status and also the exception message. Span links and async work. Links express casuality when one parent is not enough for batches, fan-in, and data check work. Message A, message B, and message C, all of them are using the same batch processor. Sampling. Keep complete traces while controlling telemetry volume and cost. You can define it as fixed rate or rate limited. Prefer source side parent aware sampling. use ingestion sampling only as a fallback because arbitrary drops can break traces. For our demo today, we are going to keep all our sampling and tracing information for the demo. We are going to start our demo with a really simple example. As you can see, I opened data grep from JetBrains, and I have here several databases in my local environment. We are interested in the bookshop, and in this database there is a customers table which contains some customers data that we are going to use for our demo today. Let me create a query here and I will show you what we have here. Select. In this database, we have ID, which is a GUID, first name, last name, birthday, and annual salary, and is the customer active or not. Okay, now I'm in JetBrains Riders ID, and we have here a customer API application, which I'm going to run it locally again. But if we go the dependencies here, we have our Microsoft Application Insights ASP.NET Core that we need to wire it up in our dependency injection in the program class, which I'm going to show you in a minute. As you can see in the line 15, we are wiring our application, our API to Application Insights Telemetry. And this configuration is coming from our app setting in this part, which we give our application insights connection string and also the sampling ratio which we discussed in the previously. In this case, it is 1, so we are able to capture all the telemetry information. This application also is using Entity Framework Core for connecting to the database, and I'm going to show you how that works. I have here a data folder and a bookshop DB context, which contains the customers DB set and the model of customer. I think we saw it in the SQL query statement. The results are the same. We have our model object and we have the configuration for this customer object that maps it to what we have in the SQL server. And the DB context is also injectable from the dependency injection from this line of code. So we are going to inject it to our APIs. In this demo, we are going to work with 3 endpoints. And let me close the tabs. They are located here. And the first one that we are going to use is the get customers endpoint. And what it does is just basically gets all the customers from the local SQL server and returns them back. And in this API, we inject the DB context, the telemetry client, as we are going to see how we're using it, and the iLogger, basically. I'm going to run customer API. And we have an HTTP file in the project, which we can call here our get customers endpoint. So I'm going to hit the play button here. As you can see, the data is coming back. And let's go to our application insights. And if I take you to the live matrix, where you are able to see the live telemetry about your application. Let's wait for some seconds. Okay, now let's go back to Rider and send some sample requests to see how this board is reacting. So let's fire again. We can see the request is appearing instantly here. I will fire another request. So we can see how that one works. So if you need any instant insights, you can definitely come to the live matrix here. Okay, let's go to the application map, which I'm going to show you. By this, you can see how your application has basically connected to the dependencies. Like in our case, we have our basically API, which has a dependency to the bookshop SQL, which is running in the local host, and Application Insights is able to show exactly what is happening in the application, which is very nice. I click on the overview to go to the main page, and we can see we got some server requests appearing in the charts, and I'm going to click here, and we can basically get more insight about this request, which here we have count of 6. So 6 times this endpoint was called in the basically last hour, as you can see in the filters. So you can also apply here filters, and it will show you the different results by your need. And if we click on the samples, and for example this one, we go to this details page where we are able to see how this tree of trace and spans inside it are basically appearing. And we can see some information for the span of the request and also our database. And if you want to know more, you can click here the show all, so you are able to see more. And also by clicking on the view all, we can have a different view of what happened in our application, which I like it better. So we can see at the first, the request came in to the get customers, it was successfully processed, and then to our dependency, which is the SQL database, and we can also see what was the query and the duration of that, and also the trace information about the command. I will head back to the IDE, and I would like to stop the project. And on the endpoint class, I'm going to uncomment these lines. I think this was the commented line before. So here I'm going to show you how you can use the telemetry client object to create a custom event on the span itself with some information, like what was the endpoint called, the query, and the row count. And also we are going to use simple log information, which I'm going to show you where these things are appearing in the tree of the trace. And as you can see also in the comments, I wrote that these informations are going to be stored in the custom events in the in the Application Insights, and also in the traces table in the Application Insights, which I'm going to show you in the portal. So let's run the application. Okay, it's up and running. Let's go to the HTTP file. I will fire the request. For 2 times, and then I'm going to show you in the portal when the log appears. Inside the overview page, we can see the spike coming to the server request. So I'm going to click here, and we go to the samples. Not this one. I'm going to search them by date. Probably we can see the newer request. Yes, there we go. Before that, I would like to show you here, we have our basically colored information about what type of events or dependency we got. This blue color means that this was the request, and this basically pattern shows that this was the dependency outgoing to the SQL server in our case. And this color purple is demonstrating the logs and also the events appearing on the span. As you can see here, we have events and trace information logged. So let's go to the view all the information, and here this is the custom events that we created for our span, which shows that SQL query executed successfully. So that was the name of it. And this is the custom dimensions are those custom properties that we added to this event, and they are basically listed here, and also they are searchable, so we can run query on them. And this is our log information. So from the iLogger that we just called with the message of SQL servers was called successfully with a record count of 1005. And with this, I just wanted to show you that how you can basically utilize events and simple log in your tracing information. Now let's navigate to the logs. From here, we can view the logs. I will close the pop-up, and here at the left side, we can see that there are several tables listed here, and we have our traces, our request, and basically exceptions, dependencies, custom events, and so on. So I am going to run a query, a KQL query here that can basically query the attributes we added to our events. Let me copy paste the query, and then I will describe it here. Here it is. So we are querying the custom events table. We are interested in the events that is bigger than 24 hours ago, and also we are filtering the custom dimensions property, the endpoint property, which we added ourselves, and we would like to basically retrieve the ones which a value is get customers. If I run this query, we should be able to see some records. The query looks fine to me, so let's again try it. I open another tab. No idea what's the problem. And yes, we got our two custom events that expected because we fired two requests. So the name is SQL query executed successfully. I expand this one, and this is our custom dimension with the properties endpoint query and the row count we added to the custom event. And if you want to see the logs, you can basically query the traces. I mean the logs that you use the iLogger to execute in your code. They should appear here in the traces information, and this is the one that we added at the end. Okay, in another example, in another endpoint, I'm going to show you how you can create a custom span alongside with the ones that are created automatically. So let's head back to JetBrains Rider, and I will open get customer endpoint, and here in this class we have a get endpoint that retrieves one customer information with its ID, and we are injecting DB context and the telemetry client and iLogger. So I'm going to uncomment this codes. So with those ones, we are able to basically create an span here. And our span is a type of dependency telemetry with the customer API get customer by ID. So this will be the name, and also it can have some extra properties on it. And at the end, what we need to do is that we need to complete our span which was successful or it failed. And in the case of failure, we can cache it on the exception and basically make this success property failed. And also we can log our exception and rethrow it, of course. So I'm going to run this project and we can see how this one appears in our tracing information. The project is running. For this one, I would need to grab an ID. I will copy here and let's go back to Rider, to our HTTP file, and let's paste this GUID here and run. Yes, we got the customer information, and I wait a little bit to this information appears in the dashboard. Then I'm going to show you how it looks like. In the App Insight, the dashboard, now I see a new spike. So let's click on it. And this time we should see another endpoint exactly. This is the new endpoint that we called with customers and QID of the customer. So I'm going to hit this one and we have one sample here. I click on it and go to the information. And this is our newly created custom span that we added. And so it will wrap the dependency span of the SQL database. And as you can see how simple it is to create a customizable span here. And this mark here indicates that this one was an internal. Click on the view all, and also this internal span is appearing in the list here as well. In the next example, I'm going to extend what we are doing in this demo to a little bit more complicated. And I'm going to introduce an Azure Storage with a queue. So we are going to call an endpoint, which is a post request, and create a customer locally in the database, and then publish an event to an Azure Storage Queue. And we would like to see then how this information appears when we have different dependencies, not only one. So Azure Storage Account will be another dependency to our tracing information. Let's go to the Resource Group tab, which is open here. Here I already created an storage. I will bring it to the left side. And here we go to our queues from the data storage section. And here I created a simple queue, customer created, which currently nothing is there. And we are going to test our endpoint and see what we get here as the result. I am back in Rider, and I will close two other endpoints which are open, and I click on the create customer endpoint. And here we have a post request for the customers, and we accept a customer object. We inject here our DB context and a queue client, which is the SDK of Microsoft. I'm going to show you shortly what you need for that if we open our project. And here I added Azure Storage Queues package. And this is also configured in the program class, as you can see in this section. We are creating a new queue client and we injecting it. This values the connection string of the storage account, and also the queue name should be added to the app settings. And as you can see, there are two other dependencies, Azure Service Bus and also the Event Hub, which I'm going to show you after this one, how you can basically send the event to Service Bus and Event Hub, and how the tracing of these brokers also work, because they work a little bit slightly different than queue storage. And that's why if we go a little bit down, here I commented out the publishing message to the Service Bus and to the Event Hub. So we just at this moment publish it to the storage queue. And every other things basically remains the same. Here we create basically customers span for our tracing, and we add the customer, we save it, and so on. So I will run the project. I go back to our HTTP file and I will fire the post request here. So as you can see, the record is created. Let's go to portal and let's see if we got any message here. First, yes, we got our created customer here in the Azure Storage Queue. And let's go back to the Application Insights, to the overview page. We have to wait for the server request to appear. I pause the video and then come back. Yes, the spike is here, and let's click. We see that the post endpoint is also appearing here in the overall list. I click on it and we should have one sample. Let's go here and see we have now extra dependencies to the queue client create if not exist. Basically this was a HTTP request to the Azure storage for creating the queue if it was not exist, and also the other one for sending the message. As you can see here, I'm going to open it here, and also we have our internal span we created. So everything is listed and traceable, and our trace list is getting more and more interesting and giving us a detailed overview of what is happening in the system. Again, I would like to extend this example. So I'm going to add a new project. I mean, a project that consumes the message from the Azure Storage Queue and insert that message to a Cosmos data store, Cosmos DB data store. And for that, I'm going to use Azure Function Storage Queue triggers. So let's go back to Rider and I'm going to show you how that works. Let's stop the project. And I will open here our Azure Function app. And for that, we have here the queue, customer created queue processor. This function app is interested or gets triggered in the customer created queue, and also we need to provide the storage account connection string to our Azure function. Then this function will be triggered, and basically there is one important fact here, that with the storage account queues we are not able to use the message headers to propagate the trace ID and such kind of informations. So we need to add those information to the message itself that we are going to retrieve the messages and add those extra information to our tracing information so that our tracing is able to continue and basically track the information here. So if we take a look at our event object, we have here the trace parent and trace state extra properties on this message. So then we are able to basically pass on this information to the next step. So the next step can attach the broken tracing. If we go back again to our customer create endpoint, here we basically call this function from publish to a storage queue. We call this function here, and from here basically we add from the current activity the ID and the tracing state to the information, and also the baggage we can add here, because also the baggage gets lost. So these are the information that you need to add in the case of using Azure Storage Queue. I go back to the Azure Function trigger, and basically what happens here, we deserialize the object, and basically we check if the customer is null, and then we are going to add the information to our current tracing state. And the next step is to basically we create a log scope, and we add the customer tags which we want to search on it, and we can start the new activity. So we create a custom span here, and then we create this document for the Cosmos DB to insert it to the Cosmos DB based on our customer information. So I kept this part as simple as possible, and then we just basically add those information and insert it to the Cosmos DB. And also to our Cosmos activity span, we are going to add some extra tag or property information. Again, these are searchable, and we just observe it item to the database. In the case of any exceptions, we can basically add the current information to our activity, which you have to do when you are creating a custom span. I'm going to run both projects and send another request to see what we get in the Application Insights. So first, let's start the customer API. And then I will start our function application. Okay, our function application is also up and running, and we have our queue trigger function listed in the functions list. So let's now fire the request and see are we able to insert a record to the Cosmos DB or not. Here we got 200 from the post request, and let's go and check the Azure. I opened a tab where we had the list of our resources in the resource group, and I will open the Cosmos DB. So we should be able to see our record appeared in the container. From here, I go to Data Explorer, and we have a tracing DB, and in this database, there is a container called customers, and we have the ID as the ID of this container and customer ID, which is a partition key. As simple as that. So as we can see, we have the record basically appeared here in the container. So this means that our application was able to create a record locally in the SQL database, then publish a message to the Azure Storage Queue, and there was also a function listening to that queue, and that function basically inserted the record to the Cosmos DB. So let's go to Application Insights and see what we have in the dashboard. Here in the Application Insight, there is a spike, so I click on the post customer. I will open this example. And our list basically got a little bit bigger than it was before. And I will here click on the view all, because we are able in this case to see all the span and events and logs one by one in a row. And as you can see, also here we have listed Azure Storage Queue, and our dependency to the Cosmos DB observed customer is also listed here, and also the tracing message customer with this ID was observed. So this is the beauty of the Application Insight and distributed tracing. So from this long process, we were able to track basically everything. Okay, let's go back to JetBrains Rider and change the way of sending the message to Service Bus instead of Azure Storage Queue. I will stop the projects. And let's go to the customer create endpoint where we publish the message. And now here I will comment out the storage queue publish, and I will publish now to Service Bus. So I will uncomment this line. Let's see what we have here. So in this function, we create our event object, and then we serialize it, and we create a Service Bus message, and we also add the correlation ID for this message as a customer ID. And also we add application properties, which is basically some metadata from Azure Service Bus message that we add here, the trace parent, which is our current activity ID, and also the state of our current activity. Basically, activity means the current span. And also we loop through the baggages that we have and add them to the application properties. And then in this part, we create a custom span for basically adding a message to the Service Bus, and we send our messages to Service Bus, and then we update the state of the span. So basically that's all. And in the case of exception, as we did it for the Azure Storage Queue, here is the same. The only difference is that with the Service Bus, we had the ability to add the parent trace and the state of the trace to the header of the message itself. So we don't need to put it to the event object as we did for the storage account. I'm going to open customer created Service Bus topic processor, and here in this class we inject Cosmos customer container provider, which is responsible for Cosmos DB operations like inserting the item. And here in the trigger, we need our topic name, Service Bus topic name and subscription name, and also the Azure Service Bus connection string. I'm going to show you shortly, but these values should be existent in the configuration. And also, we deserialize the message. And here in this part, basically, we can extract the tracing information from the message header. And so as we did it in the API project, we added the parent, trace parent information to the message header, not the properties of the events. And here we can extract it. And basically everything else remains the same in the function as we did for the Azure Storage Queue. So here we basically create scope and we insert, so we create the documents and then we create a Cosmos activity. Activity means a span again. And then basically we observe the record to the Cosmos DB and change the state of the two custom spans, process activity and Cosmos activity we created earlier. And that's all. So I am going to run the application again and see the result in the case of Service Bus. API is up and running. Let's go to the function app. Okay, both applications are running. I go to the HTTP request. Let's fire the same request. And we got 200 back. And let's go to the Azure portal and see what we have. I'm going to open here our Service Bus. And in the dashboard, we see a little bit of a spike. It means that something happened here. A request came in. I have a customer created topic, the same name as we had for the storage queue. If we click on here, for this topic, I created a Cosmos customers subscription. And our Azure function uses this subscription to process the events. Let's explore Cosmos database again. Now we can see here we have 3 records this time, and basically our distributed applications could done the job. And let's go to Application Insights and see what we get there. So I click here on the overview again, and we have again spike. Here anyways, we have our event processor also listed here for the Service Bus topic. I go to the post request. I'm interested by date. And you can see we have here our Azure Service Bus topic appearing. I'm going to here also we can see a nice a drawing about what is happening in the system. And in the view all, we can see that our Cosmos DB our Cosmos DB custom span also was created here as we expected. Everything nice and clean. We can have it as a list. And let's go and move on to see how we can configure the application to basically be able to also see the distributed tracing with Event Hubs. I'm going to open JetBrains Rider one more time, and I stop the applications. I open the Event Hub processor this time. Before that, let's see what we do in the create customer endpoint. So here, first of all, we have to comment out the publishing event to the Azure Service Bus, and I uncomment publish to Event Hub part. And let's go to the function. Let's open the function, and actually very similar to what we did in the Service Bus. We create our message and then our event data. We can provide coloration ID, the same, and in the event data object we have also here properties, so we are able to define trace parent and trace state, and also the baggage information. And then basically creating Event Hub custom send span. We have the dependency telemetry, the same exactly with the Azure Event Hub send customer created. And also here we send the event to Event Hub, and we change the state of the span, and we log the information, and basically the same. I go to the function, and here again we inject Cosmos Customer Container Provider, and in the trigger section we have our customer created Event Hub name, and also the connection string to the Event Hub, and the consumer name we are using the default consumer group name, in our example. And the same exactly, we deserialize the message, and basically here we create our trace context, we extract the information from the message header, and we create a log, and we start our process activity, custom process activity span. We can add the customer tags to it. We create our Cosmos DB item or document, and we get the container, and we basically start the Cosmos span, custom span, and we can set some tags as we did before, observe it to the Cosmos DB, and change the state of to our custom spans and log the information. So I am going to also run the application again and see the results. Go to the HTTP file and fire. Let me change here to something like that to be able to differentiate the messages. I will create the record with firing the post request. We got 200. Let's go and see what we have in Azure. Let's open our Event Hub. As we can see here, we got some spikes, so it means that there was something going on, some requests coming in, and in this namespace we have an Event Hub called Customer Created, and with one partition, which is enough for what we are doing. And let's go and see the Cosmos DB if we were able to insert the message. So in the Cosmos DB, we changed the annual salary to 150,000, and I'm going to search the record, and it is here. So successfully we were able to make our request and see the message got through the different systems, and I'm interested to see it in the Application Insights. So here, let's go back again to the overview. A new spike here, click. The same, I go to the post request, R3 example. This time, let me sort by date. Click this one. And as we can see, Azure Event Hub custom spans are appearing here. So the result looks exactly the same as the Service Bus. And that's it basically for today. Of course, there are a lot of things that you can do in the Application Insights, like different logs, tables, or possibilities, which I escaped for this tutorial because then the time could be really long. So I tried to keep everything as focused as possible to the tracing and distributed application. Feel free to play around with in the portal with the different items and possibilities and learn more. In the case of source code, the same, I tried to explain the important part so we don't lose a lot of times, but I'm going to push the code to the GitHub. You can download the code and review it. In the case of any questions or unclarity, don't hesitate to write your question down below in the comment section. And I would like to thank you for watching and hopefully see you in the next video. Until then, take care. Bye.